Good morning. Did you know that in over 60 years of nuclear power generation, with over 18,500 years of cumulative reactor years of generation, there's only been three significant accidents in nuclear power? This suggests that while accidents do happen in nuclear power, they are extremely rare. Safety in nuclear power is paramount to developing clean energy, generating clean energy from a business perspective, and for maintaining electricity to all of its customers. According to the Nuclear Energy Institute, nuclear power accounts for over 20% of all electricity generated in the United States and more than 50% of the clean energy. Without the safe operation of these nuclear power plants, more than 75 million homes will be without power. My introduction to nuclear power was not planned. One fateful day, shortly after high school, I was walking home from the corner store. I was walking back to the house known as the greenhouse, not because it had a lot of plants or because it was made of glass, but because it was green, bright green, which is how I think he found me because you can see my house from the International Space Station. Google it. Well, I'm walking back home up to the porch, and a car pulls in my driveway. Being inner city Detroit, I'm a little skeptical. Why is this car pulling in my driveway? Out of the driver's side window, I hear in the sternest, deepest voice, "Hey, what are you doing?" I turn and I look and I stare, kind of just creep back up on my porch a little bit more, just a little startled, don't know what's actually happening. The guy gets out of the car, wearing all white, dressed to a T, sharp, shoes shine, you see your face in them. I mean, he looks good. He says, "I didn't mean to startle you. Just wondering, what are your plans for the future?" I had no plans. I graduated high school bottom of the class, had no college application submitted, had no scholarships, didn't take the SAT, didn't take the ACT. I was going nowhere. I had nothing to tell him, so I just shrugged. I said, "I got nothing." So, well, how about this? Tomorrow I'll come pick you up, take you out to breakfast, and then I'll bring you into the recruiting office and I'll tell you a little bit about the United States Navy. There'll be no commitment or anything like that. We can just talk. So that sounds like a good idea. I'll see you tomorrow. Saying that, I didn't expect him to show up again tomorrow or for me to join the United States Navy. But I just went in the house, ate my snacks, watched TV. Next day I got up, he was there. Took me out to eat, took me to Wendy's, but at this time I love Wendy's. And then he took me to the office. He started telling me about the United States Navy, the everyday ins and outs, a little bit about the different careers. And he says, "How about this? How about you take this practice exam and we'll see what you qualify for. And then we can talk a little bit more specifically about things that you can do." So that's fine. I took this practice exam, scored really high on it because I was lazy, not stupid. He said, "Oh, well, I got a great opportunity for you. You qualified to be a nuke." Like, "A nuke? What's that?" He's like, "A nuclear operator." I'm like, I'm a little skeptical about that because only thing I know about nuclear generation at this time is Chernobyl, which was terrible, 3 Mile Island, which I didn't know much about. I knew it was bad, and I knew about Hiroshima and Nagasaki, which are horrific. So it wasn't something I was interested in. I'm like, I don't know about that, man. That doesn't sound like anything for me. He's like, "Well, let me tell you a little bit about it." It says the Navy operates more than 12 aircraft carriers that are nuclear powered and even more submarines. They have a great track record. It's safe. I still don't know about it. I'm like, I don't know, sir. Maybe there's something else. He's like, "Well, let me tell you this. Nukes get a huge signing bonus and they advance fast, which means more money in your pocket." My eyes lit up. Sign me up. I'm down. Let's go. Unfortunately, what I found out is a lot more interesting than what I thought. Nuclear power is safe. It is critical in our fight against climate change by being a clean energy source. So I went from having no direction at all to a career field that interests me and that contributes to a sustainable future. I hope to share some of those insights with you today. What I'm looking to get out of this speech and what I want to talk about is, what is nuclear power? I'm going to talk about Chernobyl and what we learned from Chernobyl, the accident itself, and how it helped shape the future of nuclear generation. We'll talk about the safety record from those accidents and the safety record in nuclear power as compared to other energy sources. We'll talk about what makes nuclear power clean energy. So, what is nuclear power? Nuclear power is the process of heating water through fission. That is it. We just do all this just to warm water. So what we do is we load the core full of uranium-235 atoms. These uranium-235 atoms are inherently stable. We bombard their nucleuses with neutrons, which gets them excited, and they split. When they split into two elements relatively charged, usually krypton and barium, and they emit three neutrons, which go out to cause more fissions and a lot of energy in the form of heat. That heat is what we're after. That heat is used to warm water. Now, warm is a relative term. It heats this water up to approximately 600 degrees under about 2,200 pounds of pressure. That water is then pumped through a steam generator. The steam generator has a primary and a secondary side. The primary side is the water in the reactor core. This is in pressurized water reactors. And a different set of water in the secondary side of the core. The hot 600-degree water is pumped through tubes to heat the secondary side water and boil that and turn that to steam. That steam is then sent over to a turbine, spins the turbine. Turbine is connected to a generator, which spins the generator, which creates electricity. That water is then condensed, that steam is then condensed back to water and pumped back in the steam generator to start the cycle again. And the primary side water in the steam generator tubes is then pumped back into the reactor core to help moderate neutrons and to warm up so that we can start this process all over again. And that's nuclear power. All of these controls here is to help with that. So, what happened at Chernobyl? Chernobyl is one of the most infamous accidents in nuclear power. It is the one. It is the one we all have to learn about. It's the one. So, at Chernobyl, their design was a graphite moderated reactor. So their reactor, instead of using water like we use or most plants use today, they use graphite to help slow neutrons down to a level to cause fission. They also had control rods, which are the rods used to help control the nuclear reaction by absorbing neutrons, that were cadmium tipped. Not cadmium tipped, I apologize, graphite tipped, which means that they helped create power instead of before they started absorbing neutrons. They also had a positive void coefficient, which means that as temperature and voids grew within their core, it caused power to go up inside of their reactor core. So Chernobyl wanted to run a test. They wanted to see how long they can provide core cooling after a reactor trip and the turbine trip just from the coast down of the turbine and how much electricity to produce during the coast down. So they went into this test. All of the initial conditions weren't lining up, but they went forward in the face of uncertainty anyways. In order to perform the test, they had to disable a bunch of automatic safety features, including their emergency core cooling system, which would have came on after the reactor trip to help cool because they needed to see how much the turbine did without the backup of the emergency core cooling system. So they moved forward in the face of uncertainty. They tripped their reactor. Once they tripped their reactor, their backup water source didn't come on. So they had core cooling just provided by a slowing turbine. That, coupled with warmer feed waters coming in, caused voids in their core. These voids, as the voids grew, the positive void coefficient kicked in and made raise power. As power went up, temperature went up, voids got bigger, power went up, more temperature went up. So as the rods fell in the core, the graphite tip on the rods actually helped the fission process, which exacerbated the problem. So after that, chain reaction, power going up, temperature going up, voids going up. We hit an explosion and the worst accident in nuclear power history. And a pretty cool TV show. But that accident from the explosion alone killed 28 people. 3 more people died directly from acute radiation poisoning in the cleanup effort in the following days. It's estimated that an additional 4,000 to 8,000 people, according to the Nuclear Energy Institute, died from indirect effects after the fallout of Chernobyl. So that's from thyroid cancers, iodine poisoning, and things of the such. 4,000 to 8,000 people. That's very tragic. How does that compare to other sources of generation? Well, according to the College of Natural Sciences, from the year 2009 to the year 2020, fossil fuels accounted for 460,000 deaths from direct and indirect operation. Even solar energy has its toll. Solar energy accounts for approximately 440 deaths per year just from the installation of the solar power panels on roofs. Well, you may ask, well, what about 3 Mile Island and Fukushima? You got to add those numbers in, correct? Fukushima, if you add Fukushima, 3 Mile Island, and Chernobyl together, the direct deaths from those 3 accidents from the nuclear power are 46. Indirect is still 4,000 to 8,000. Well, what about from normal maintenance and normal operation of a nuclear power plant? Nuclear power accounts for nearly 0 deaths per year from operations, maintenance, outages, and normal everyday operations. The average is 1 death per 33 years. So if you add up all the direct deaths from nuclear power, which is 46, and the nearly 1 death every 33 years, you see that nuclear power is not as perilous as what we once thought it was. What did we learn from these accidents? So Chernobyl, we learned about design. All reactors now are designed with negative reactivity coefficients, which we'll talk about in a little bit. 3 Mile Island, we learned about training and the need for training. As you see right now, I am sitting in the simulator at my nuclear power plant. This is where I come to train every 5 weeks. 20 hours of training in the simulator, 20 hours of classroom training. 2 tests every 5 weeks. We do a simulator exam and we do a written test. If we don't pass either one of those tests, we lose our license to operate the nuclear reactor here. You have to be remediated, and if you fail the remediation, you're just out of a job. So training in nuclear power is very important. Safety is also very important in nuclear power. As we talked about, operational, we have 0 deaths a year. And that's because at all nuclear power plants, they have a saying, all injuries and events are preventable. Now, when you first think about that, you think about how humans are fallible. They make mistakes. This is true. We're not trying to stop humans from making mistakes. We're trying to stop the events from happening from those mistakes. So take like you're walking down the stairs, for example. If you're walking down the stairs carrying books or carrying laptops in your hand and you slip and fall, there's nothing you can do about it. You're going to fall. You're going to hurt yourself. You're going to break your ankle, leg, or worse. What we operate in is the fact that take the time needed to do the job correctly. So if you're going to walk down the stairs, don't carry something in both hands. If you have to, use the elevator. There are elevators here. If you can't, get help. But hold on to the rail so that if you do slip, you can catch yourself and prevent the injury or prevent an event. Because humans are fallible and do make mistakes, but if we stay with the safety precautions and safety protocol, we'll get there. And you may think, well, how do we go about that? Because all injuries and events are preventable. If anything happens at the plant, all work stops, everything, until we talk about it. We understand what happened, the why it happened, and what we could do to prevent it, and we take actions to stop it from happening again. That's at every nuclear power plant, and then we share that experience with every other nuclear plant out there. It's called operating experience, and you can look it up. We send it out to every nuclear power plant. Now that everyone knows the mistakes we made, and we know the mistakes everyone else made. This is how we stay safe and foster an environment of safety at nuclear power. So what makes nuclear power clean energy? Well, nuclear power protects air quality. We are 0 emissions. Nuclear power have 0 emissions. Nuclear energy also creates the most power on the smallest footprint of all energy sources. A typical 1,000 megawatt nuclear facility in the United States is a little bit more than 1 square mile to operate. According to the Nuclear Energy Institute, wind farms require 360 times more land, and solar farms require 75 times more space than that. So to put that in perspective, you would need more than 3 million solar panels to produce the same amount of power as a typical commercial reactor, or more than 430 wind turbines. Also, nuclear power fuel, all the waste in over the 60 years of production can fit on one football field in less than 10 yards. So, in conclusion, we talked about nuclear power and the safety. We talked about the clean energy perspective. I gave you a little insight. Hopefully, this clears up anything and we can move forward. And you can now see nuclear power as a clean energy source and how effective it can be and operate safely. Thank you.